We have tonight three exceptional speakers, awesome speakers. I'm going to give out the credentials for all three sequentially, and then we'll let them transfer between them through the presentation. I'd like to introduce the first speaker, Nikita Ogievetsky. He's the head of Applications and Solutions Engineer and a Solutions Engineer for Scalar. He's got 20 years plus of industry experience and specializes in delivering complex analytic solutions, building business analytic solutions for Fortune 100 companies. Next speaker on tonight's agenda is Josh Dev, the product engineer for Scalar. He formerly has worked at SaaS companies building data analytics solutions. And now the very first speaker who's going to speak tonight is Karun Bakshi. He's the VP of Product Marketing for Scalar. He's formerly held leadership roles at Oracle, Microsoft, and Pivotal. And what's significant about those three companies is we've had prior Database Month events at all three of those companies going back 5+ years. If anyone has been to a Database Month event at Oracle, Microsoft, or Pivotal, that means you've been with us for a while. Type in the chat, pat yourself on the back. In the meantime, I'm going to hand it off to Karun.
Great, thank you, Eric. Hopefully everybody can see the screen. Great, excellent. Well, good evening, everyone. Thank you for joining us today to learn more about Scalar. Today, we'll be speaking about data warehouse as code, the secrets to using SQL to build your data warehouse in minutes. The agenda for today's talk is broken up into 3 sections. We'll speak a little bit about the background of the market and the motivation behind Scalar. Then we'll dive into some of the core concepts for Scalar and do a few demos to show you how the product works. And then we'll conclude with a discussion around a real-world customer use case. So that's sort of the agenda for today. Next slide, please, Josh. These are the speakers, as Eric already introduced us. I'll be covering the first part. Nikita will talk through the customer solution and demo. The demo will be done by Josh. Thanks, Josh. Next slide, please. So when we talk about data warehouse as code, it's helpful to understand some of the context behind how we got here and what has preceded us as a community. When you think about the first generation of data warehouses, the names Oracle and Teradata come to mind. And generally, they tend to get associated with on-premises deployments, tend to be very hardware-centric. The only way to scale it was through vertical scaling of the systems that were running those platforms. And they tended to be somewhat siloed. You had to read the data ingest into proprietary formats before you could do anything useful with it. And the only way to sort of build those data warehouses was to define the structure ahead of time using DDL, and then process your data and load that data into the data warehouse. And that could get expensive over time. As you started to scale the system, those were quite expensive systems. Now, fast forward, maybe 3 decades from when they originally came out, about 10 years ago, with the advent of cloud, a couple new sort of players arrived on the scene, things like Amazon Redshift and Snowflake, to try to take advantage of cloud efficiencies. And so they reimagined what it would take to implement a warehouse in the cloud, and they made some big changes, right? They went from on-premises and hardware-based deployments to cloud and software and SaaS-based deployments. They went from scale-up systems to scale-out systems. And they were able to segregate the scaling to be independent. So you could scale storage separately from compute. Now, those were the things they changed, and that was a significant leap forward. But there's a lot of things that they kept the same. They kept the static DDL and DML. You still had to define the structure of the data warehouses ahead of time. You still had to read data into proprietary formats and manage and run queries against that data. And although they were initially coming out with cost savings because of the independence of storage and compute scaling, over time it has proven to be quite expensive. As a lot of customers are finding out, it gets quite expensive quite quickly. So next slide, please. So if you think about why that has been the case, the reason for that was that the problem set that they were solving hadn't really changed very much. And the world we live in today is very different. The nature of data and analytics has changed. There's a significant race to create value from data. And what that means is a lot of organizations are trying to combine different types of data. There's, on the one hand, you've got the business critical data, things that you've traditionally held in data warehouses, things like customer name, customer address, and quarterly sales. And these tend to be relatively slow changing. They're relatively smaller in size, but they have long-term value. What organizations are trying to do now is they're trying to combine this with business context data. This tends to be rapidly changing by the minute, by the day, by the hour. Because of the fact that it's rapidly changing, it tends to be much larger. And it has fleeting value, things like stock values, IoT measurements, social signals, weather data, and trying to combine that data, the business context data, the context in which the organization is operating their business, with critical data, and trying to find insights that you can use to either create differentiation or capture business opportunities that are fleeting. That's really what organizations are trying to do. And they're trying to combine this data and apply AI and ML and answer complex questions, things like, what should I recommend to customer X based on what they recently did on a social platform? Or did such and such a person cross the border and that's a person of interest, and how can I correlate that with border crossing data that's coming in from various border checkpoints? So those are the kinds of problems that organizations are trying to solve now, and they're very different from the kinds of problems that traditional data warehouses solved. So next slide, please. So how would you go about deriving these insights? So we posit that insights really are a function of data, which is data that you're collecting from all the different sources, whether it's the core data that you're running your business on, the critical data, but also the various signals that you're getting from IoT measurements and social signals, and trying to do computations on it and trying to enrich that data before you do queries to derive insights on it. So when you think about the technologies that can help you with that, next slide, please. They tend to fall into a couple different camps. There's the technologies that are oriented towards handling query-centric workloads, things like Snowflake, Vertica, Teradata, Amazon, Athena, Presto. They are well suited to run declarative SQL queries, and they can do that at scale quite quickly. So they have their advantages. They use SQL queries. They work with your existing investments in BI infrastructure. Obviously, you can leverage the familiarity with SQL and the large availability of skill set around SQL. But some things they haven't changed, things like the siloed nature of the data, the fact that you have to ingest that data and duplicate that data into the warehouse, the fact that you still have to define a priori the structure of the data warehouse, the fact that you can't do a lot of computation on the data, you can primarily just query the data, and the fact that they have rising costs associated with them. On the other hand, you've got compute-centric workloads that tend to fall in the domain of technologies like Hadoop and Spark. These are scale-out technologies, and you can get away from the silos. You have complete flexibility in the kinds of computations you want to do. But again, these technologies tend to have limited skill set availability in the marketplace. A lot of them are open source technologies, so they don't have the enterprise readiness that you would expect from a commercial offering. A lot of organizations end up building their own technology stacks and data pipelines on top of these technologies. And so organizations are sort of left to bounce between these two systems, right? You have to sit there and process the data with one set of technologies and then move it somewhere else to do the querying. And of course, this takes up a lot of time, which you don't have if you're trying to derive data and insights from fleeting data that's changing rapidly with time. You don't have a lot of time to extract the insights. And of course, it's higher cost. Why would you ever want to store the historical weather that's correlated with your business operations or the social signals that you're getting? They make sense in the moment, maybe for a day, maybe for a week. But long term, it doesn't really make sense to pay for it or to even bother loading that into a data warehouse. And that's sort of the space that Scalar fits into. Scalar covers that white space. It combines the worlds of relational and compute. It helps you do both of them with one solution. Next slide, please. So Scalar combines the best of both worlds. We provide you the flexibility of the declarative SQL query paradigm, the complexity of computations that you can do with more compute-centric platforms, all in one platform, while continuing to work with your existing BI investments, things like Tableau, and of course leveraging familiarities of the skill sets that you have, and avoid a lot of the data duplication and silos. So with Scalar, you don't have to read into proprietary format. We can work straight off your data lake or Streamhead, if you will. And you have the ability to have malleable schemas, so you don't have to define them up front. This is something you can shape and reshape and configure with code, and we'll talk a little bit about that in a couple of minutes. And then finally, Scalar comes out of the box as a commercial offering with enterprise-ready features, and of course, comes at a significantly lower cost. Some of the customers we've been involved with, we've seen easily a realization of 10x lower TCO for Scalar. Next slide, please. So in that sense, we consider Scalar to be the ultra-modern data warehouse, sort of thinking about the business problem and how it has changed from what it was before to just tracking business critical data to a different problem, which is to combine that critical data with contextual data and try to derive insights quickly. And in that sense, Scalar provides a number of features that are that are differentiated, which is the ability to do both querying and compute on the same platform. So not just simplistic compute, but fairly advanced, complex data pipelines and data transformation pipelines. The ability to change your schema and not have to be stuck with the a priori defined schema that you have for the data warehouse. The ability to work straight off the data lake without having to ingest into a proprietary format. And of course, all the features that you're used to with traditional database technologies, things like transactional integrity and ACID compliance, snapshot and recovery and backup built into the platform. And most importantly, the fact that you can build data warehouses through software. So this is a software-defined data warehouse, what we call data warehouse as code, that really matches the agility that is required to keep up with the state of the data landscape today. The rate at which data changes, you need to be able to reconfigure and capture the data and the insights quickly, and software is ideally suited for that. Next slide, please. Before we dive into some of the features and concepts for Scalar, it's helpful to look at the architecture for Scalar. In the center of the diagram, you'll see the architecture for Scalar, which is Scalar is deployed as a collection of VMs that are managed VMs that run on your VPC in AWS Cloud. They can read data off of various sources, whether it's flat files sitting on your Amazon S3 data lake, things like CSV, JSON, and Parquet, or even image files, or even proprietary data files. It can also read off of streaming data sources like Kafka, or even structured data sources like Oracle and Teradata. What it does as a result of reading this in is to hydrate tables in memory that are then presented as a programming target abstraction that you can write code against using the Scalar proprietary Scalar Data Notebook IDE, which is purpose-built for building data applications. And we'll spend a lot of time in the demos working with the IDE and show you a lot of the features that really accelerate developer productivity. Once you've built the application, the data processing application with the IDE, you deploy it to the Scalar runtime, and the platform automatically parallelizes your code, partitions the data behind the scenes. You don't have to do any of that. You just simply write the business logic and processes the data to generate the final collection of tables that essentially form the data warehouse, or the data mart, if you will, for what you want to do with it. So then at that point, you can connect to it through any ODBC or JDBC compliant BI tools, things like Tableau and Qlik, or even serialize it back out to disk as a data set, for example, that you want to use for ML model building activities with tools like Data Robot, and so on. So that's essentially the architecture for Scalar. Maybe next slide, please, Josh. Let's talk a little bit about how to build data warehouses, and let's compare that to how data warehouses have traditionally been built. To many of you who have built data warehouses, these screenshots here are probably very familiar. You spend a lot of time up front understanding the domain, making sure you capture all the relationships, all the primary key, foreign key relationships, make sure you understand how to model it properly. And then you have to spend a lot of time defining the schema of it by using DDL. And once you're done doing that, you have to spend some time understanding what kinds of queries will be run against that data structure and that data warehouse, and then go back again and optimize the schema to make sure that you're able to partition the data, build the right indexes for the queries to work in a performant way. And then once you're done with that and you've created the data warehouse structure, you're doing a lot of the processing of the data and computing all the aggregates before you can even load the data into the data warehouse. And what this leads to is a very static and brittle form of building data warehouses, because there's a lot of work that's done up front. It tends to lead to long lead times. Every time there's a change, you go through the cycle again of rethinking the schema, re-optimizing the queries, re-optimizing the table structures, etc. And it's not really well suited to the modern environment we find ourselves in, where the data is changing quite quickly and you want to take advantage of it quickly. It really is suited for the traditional data marts, where data was slow changing and the environments were relatively static. So next slide, please, Josh. So what does Scalar do differently? So Scalar works directly off your data lake. We can read in files from the data lake. We can read in your, let's say, CSV files. We create tables in memory. This becomes a targeted abstraction for writing code against. And then you just simply write business logic in SQL and Python and incrementally and iteratively transform the source input into the final input, through various intermediate steps into the final set of data mart tables that you want to make available for querying purposes or for application access purposes or whatever reason you want to generate that table structure for. Of course, you can make it available through an API endpoint as well. And what this leads to is very rapid development process. You don't have this massive lead time of planning and building of the data mart and structuring of the data mart, the data loading process. You just fluidly intermingle the loading process with the code development process, with the schema definition process, with the query process. And you can do this in an incremental way. So a lot of times when you're dealing with data today, you're dealing with new sources of data. You don't know what they are. You have to discover them. You have to explore the data, and you want to play with that data. And you want to incrementally add it into your data warehouse definition. And that's something that building with code makes it very easy to, in a very lightweight manner, reconfigure the data warehouse pipeline. Moreover, you can take that pipeline and you can take portions of that pipeline and parameterize it, modularize it, and then reuse it in other pipelines that you're building for building data warehouses. And as I mentioned earlier, you can write the code once, write your business logic once, and redeploy to a completely different production environment. You could be building with one instance in a development cluster, but be deploying to a 100 node cluster in production, and the platform will automatically parallelize your code, partition the data in production, and run it in an optimized fashion without you having to do anything at all. That, in a nutshell, is Scalar. So maybe we can take a look at what that looks like in a demo. Josh will help us see how do you build a data warehouse in minutes by just simply writing select statements. So over to you, Josh.
Thank you very much, Karun. Welcome, everyone. Today we'll be going through a series of demos outlining key features in Scalar. And after each demo, we'll recap what we saw. So in the first demo, we'll be looking at building an end-to-end data mart in Scalar. So here's a set of CSV files sitting on an S3 bucket. In traditional data warehousing, you'll need to spend time creating schemas for these files. You'll need to know the exact types for your columns. You'd also want to know how to create indexes for your tables. And furthermore, in modern day workloads, you're probably faced with a situation like this. So you'll need to work with both structured and semi-structured data, like compressed and uncompressed CSVs. You might have JSON files from IoT devices. You might also have Parquet files from your data lake, like Hadoop. But today we're short on schedule, and we also don't have days or weeks to gather the expertise and information required to do this. So with Scalar, let me just show you how easy it is to load this data and build a data warehouse. So Scalar can be accessed through the browser. I'm going to put the link to my cluster here, and then I'm going to log in. So because it's accessed through the browser, I can zoom in and zoom out. I'm going to zoom in a bit for the presentation. This is the main dashboard of Scalar. There are many capabilities here, but today we'll be looking at Load and Notebook. Load is used to consume data into Scalar, and Notebook is the IDE which we can manipulate the data and build data applications. So let's jump into Load. So I pre-configured this Scalar cluster to connect to the bucket that we were just looking at. Under File Types, we'll see a number of file types we support natively. So in that bucket we just saw, we had CSV files, we had JSON files, we had Parquet files. Let's start by filtering by CSV. Now I'm going to navigate to the bucket. I'll choose my folder and hit Done. So under Configuration, you should see very familiar options for parsing CSVs. We have a record and field delimiters. I'll click on Allow Quoted Record Delimiter. Then under Discover Schema, I'm going to hit Discover. So Scalar is going to preview our files and discover our schemas for us. Let me just click into Create Table. And now the table names have been derived from our file names. So let me start creating our tables just by clicking this button. When I click on any of these schemas, I'll see exactly where the tables are coming from, so which files are coming into the table, and also the column names and the column types. Now you may ask, it's very easy to look at CSVs and derive this, but what about JSON and Parquet? So now let's load our JSON files. I'll click on JSON, click on the same folder, hit discover, and now it'll pick up our JSON files. Now I'll hit create table, and in a similar manner, I'll have what's building this table, so this JSON file, and also the columns and the types for that table. And yes, you can go in and manually change these. So now let me finally load our Parquet files. I'll click on this folder again. I'll hit discover. So Scalar supports JSON with nested fields, and it has full support for Parquet with full schema detection. So I'll create the Parquet tables now. So just in the same way, I can click on these schemas, and I'll see the Parquet file that's pushing into this table, and also the column names and the column types. So you can see how it's quite intuitive and easy to use. So now let's jump in to the notebook, which is our IDE. So I'll click on the Navigate to Notebook. Let's create a new project for database month. I'll just call it database month. And we'll click into it. So this is Scalar's IDE. On the left-hand side, we have our resources panel. We can see the tables that we've just loaded in. Under that, we have SQL statements. We have our table functions, Scalar functions. On the top, we have our SQL pane. This is where we write our SQL. On the bottom, we have our SQL Graph. And we'll get into these in a moment. On the right-hand side, you'll typically have your configuration panels. You'll have your preview panes. Each of these panels can be undocked and moved around. So here's me undocking the SQL Graph, enlarging it, and I'll try my very best to undock them so that you get a good view of what I'm typing as we go through the demo. So on the left-hand side, we have the tables that we just loaded. This is an e-commerce data set, and let's preview, let's say, the orders data set. So now I can see a quick preview of any tables I've just loaded. In addition, I have various functionality and to work with, but let's just start writing some SQL. We'll start by a simple select. As I type my select statement, you can see that Scalar provides full auto-completion of the SQL that I write. And this namespace is derived based on the tables that you load, their columns, Scalar functions that you've written. In this e-commerce dataset, I know the orders dataset is related to the order items dataset. So orders to order items is a one-to-many relationship. So why don't we join the two and build a data mart out of that? So I'll select everything from my orders dataset, and then I'll just join it to my order items dataset. Let me pop this out. And I know that their column is order ID. Now I'm going to hit this green play button. So on the bottom here, we have a SQL graph. And this is Scalar's visual representation of our data flow. So it's a set of operators being run, and Scalar has partitioned and distributed the data across my cluster. It executes this graph eagerly from left to right, and the final result is actually the result of the final node. So really, as a developer, I only need to focus on writing my business logic, which is just a SQL statement. And I don't have to worry about the underlying data and infrastructure management. So you can see the result of this statement on here on the bottom right. Let's say this is good enough for my data mart. Let's quickly build a data mart out of this. Before I do that, I just want to do one quick thing. Let's take the results of this and also export it back to S3. I can also export it to other sources, but today I'm going to export it back to S3 and a particular bucket that I have access to. So I just clicked on this node, config, and I dragged an export node down to the graph, and now I'm configuring it. I'm going to select all my columns. We'll choose single CSV. We'll choose AWS target. Now let me copy over the name of a bucket I have write access to. So this is our S3 path. So we'll call this /export, let's say data mart.csv. We'll provide these field and record delimiter options. And then we'll click on save. So at any point in time, I can drag an export node and export the results back to my graph. So you can just see how easy it is for me to click and drag nodes and build a data application. So the next thing I want to do is I like the results of this statement. I want to build a data mart and connect to it with BI tools. So Scalar supports a variety of BI tools over JDBC and ODBC. So I dragged a publish table node, and now I'm going to configure it. So the publish table node, let's just call, let's publish my table as my first data mart. It's okay to overwrite the existing table because we don't have one. I'll select all the columns and I'll hit save. So under out, we have a variety of options we can do that, and we've just demonstrated both export and publish table. After I publish my table, you'll see the table on the top left under tables. And as I click on it, we can preview it. Publishing a table allows us to access it externally through BI tools. Now let me jump into Tableau and show you how easy we can connect to Scalar. So this is Tableau online. I'll create a new workbook. Under connectors, I'll choose Spark SQL. So this is a driver we'll be using today. And I will copy my URL from my Scalar cluster. So that's database.month.qa.scalar.io. Paste it in. I won't be sharing my authentication details, but I'll sign in. And in just a few moments now, I've connected to my Scalar cluster. Under schema, I'll choose the default schema. Under table now, I'll see all the tables I had under my resources panel. And my first data mart was the one we just created with that simple select statement. As I hit update now, Tableau has the full connection to my Scalar cluster. As we create and pull in different dimensions and metrics, I can build dashboards, and these queries will be running on top of Scalar. So what you've just seen is we've taken flat files on S3, we pulled them into Scalar, and we've built a data mart that we can now connect with Tableau. All right, so that was amazing. Now let's do a bit of data exploration. So we'll jump back into Scalar. And now I noticed that in looking at my data set, I can actually aggregate some of this data together. So I know that in this data set, under order items, we have a mapping, we have a product ID. So let's say I want to find the total sales and the number of products sold for each of these product IDs. So let's take our query here, modify it just a little bit. So after the left join, we'll group by the product ID. And then on the select, we'll select the product ID. And then we'll count the number of rows as the number of items, the total number of items, and the sum of the price as the total sales. And let's also throw in, let's say, an order by the number of items. Now I'll execute this statement again. And Scalar has produced a new graph for us, and we see the results in the bottom right. So let's take a closer look at the graph we just created. I'll pop this out. So in each of these nodes, we see that we have metadata based on the operator. So each node tells us exactly how long it ran. So we get at a glance, we can see which operations are taking longer than others. We also see how many rows are produced in each operation, and also this queue, which allows us to debug and data distribution across different nodes. So let's go to the end and let's view the schema. As we view the schema, one of the things that we can do is we can trace back where the data is coming from. So essentially the data lineage. So some columns might be coming from source tables, such as product ID. Scroll left. And some columns are coming from derived from the query. So total sales and number of items are actually come from a group by, while product ID comes from a source table. Now, in our preview window, we see we have total sales. Let's say I'm interested to know the distribution of the column total sales. I can right-click on it and click on Profile. So Profile will give us a histogram of the values in this column. While this is loading, let me also generate some quick aggregate summaries. The granularity of this histogram seems to be a bit too small, so let's change the range maybe to, let's say, 50, the bucket width 50. On the right, we can see the max value, the min value. On average, these products sold about $412. And we can see the majority of them were about less than $500. In addition to this, let's say I can click on correlation, and I can see whether two columns are correlated. So number of items had 0.704 to 1 to total sales. And that makes sense because as you increase number of items, you should be increasing total sales. So that's correlation makes sense. Great. All right, so that was a whirlwind tour of an end-to-end building data mart and doing some exploration. So let's go back to our demo and do a quick recap. So in the demo that you just saw, we loaded files of various types sitting on S3. We built a data mart using a simple select statement. We then connected to that data mart with Tableau. And then we went through some data exploration exercises, including profiling of a column, correlations between columns, and also data lineage. So I'll hand it back to you, Karun.
Great, thank you, Josh. Next slide, please. So as you just saw, you can use the humble select statement to build a data mart just from scratch with raw data and end up with something that you can access from Tableau. But wait, there's more. You can actually enhance that simple select statement with scalar functions and table functions. Most of you are probably familiar with these functions. Essentially, what they allow you to do is build very sophisticated data transformation pipelines, build very complex data marts and data warehouses, and fluidly intermingle both the schema definition of the final data warehouse along with the computational enrichment and processing that you would do. And so the scalar functions are defined using Python. In Scalar. Essentially, where you can use that to build any arbitrary logic, any business logic that you want to build, use that to enrich the data, use that to also evolve the schema because the end result, the return value of the scalar function is always a new column that gets generated in the final result set. On the other hand, you've got the table function also, which is built using SQL. As you're probably familiar, you can parameterize the table function where you can specify the table as a parameter. And you can generate a new table based on any set of input tables. And this is useful, obviously for encapsulation and code reuse, but also for increasing the quality because you can build portions of your logic, portions of your pipeline, and test them independently, and then reuse them in different flows and be guaranteed that it's been tested and is easily reusable and parameterizable. And this is how you go from building data marts and data warehouses from weeks to months to minutes. To basically be able to write code, change the schema by just simply by writing code, adding a little bit of computation to enrich the data and get really interesting insights. So let's take a closer look at scalar functions in Scalar. Here's a code snippet in Python. As you can see, it's a regular Python function. What's interesting here to pay attention to here is this prototype line, which is defining the function name along with the parameters. The parameters are coming to it from the source tables that you're pulling columns from. So in this case, for example, we have the function is supposed to compute the distance between 2 points on the Earth's surface. You have two latitude, longitude pairs of values, each one coming from a different table. They're passed in as parameters. You can build arbitrary logic in the body of the function. And then your return value essentially gets used to populate the new column in the result set. And of course, as you write this code, you can have arbitrarily complex code in the body of the function, but you can also leverage existing Python code. So you can have your own libraries that you can import, as you can see from this code snippet at the top. You can import, the math library, and you can import your own proprietary libraries. You can import open source libraries. And as we'll see in a few minutes, you can use that to build and deploy machine learning in production as well. So let's take a look at an example of this in action in Scalar. So Josh, perhaps back to you.
Yeah, thanks, Karun. So just to recap, what we did earlier was we wrote a simple select statement, and we were able to connect to a data mart using Tableau. So the result of this select statement, we have number of items, total sales, and product ID. Let's write a simple scalar function to convert these total sales. Let's say the currency is not what we expect, and we want to convert the currency. So let's write a simple function to convert currency. So scalar functions can be accessed right here in SQL.py. So any functions that we write here are added to the namespace of functions that we can use in our SQL. So scalar functions are written in Python. You can import your favorite libraries, as Karun showed. Here is an example of a very simple one. Basically, it's written in Python and it adds one to a column. So let's write one that converts currency. So in Python, I can write a function with def, convert, I'll call it convert currency. We'll pass in a column. And scalar functions take columns as input and return a single value as output. So let's have our currency equation just multiplying the column by 8.18. I'll hit save. Dock this back in. So now let's apply our currency conversion function to the SQL statement. We wanted to convert total sales. So scalar functions can be used just like SQL functions. So I'm just going to call it convert. Pop this out. Convert currency. And I'll wrap it around our sum of b.price. Now I'll hit the execute button again. Pop this back in. Now Scalar has created a new graph, and it has executed our scalar function and produced our results. So these scalar functions are applied row by row in a distributed and parallel manner. They'll use all the CPUs and nodes in your cluster, and they are as simple as just calling a SQL function. In fact, we can use them interchangeably. So let's say after I executed this function, we see a bunch of decimal points. Why don't we round this under total sales? So let's just call the SQL round function around my convert currency. So now Scalar has created a new graph for us and has executed. It has used our scalar function to convert the currency, and then it has applied the SQL function on top of that to round it. So you can see how easy it is for us to write Python functions and use them interchangeably with SQL functions, and just in general write SQL and Python very easily. So now let's recap what we just did. So in this demo, we created a simple currency conversion scalar function. We took our existing SQL statement and augmented it with our function. We then showed how scalar functions and SQL functions can be chained together. And right here is a good example of using scalar functions that Karun will get into, but it's essentially we can use SQL and Python to generate new features. All right, back to you, Karun.
Great. Thank you, Josh. Yeah, as Josh mentioned, you can use it to, let's say, curate your data set. If you're trying to build a data model using machine learning, this is a great way to process your data and generate new data sets. Next slide, please. So as we just mentioned, you can enhance the select statement with scalar functions and table functions. We took a look at an example of a scalar function. Similarly, you can do the same thing with table functions. Just to recap what a table function can do. Perhaps next slide, Josh. is, for those of you who, most of you probably already know this, but for those of you who are not familiar with it, you can take a regular SQL statement, something like this, where you're selecting from two different tables and joining them and maybe projecting some of the columns into a new result set. You can parameterize this. So this is where you can, for example, take the input tables and not provide literal names for tables, but actually just provide parameters T1 through Tn. And that becomes the source of the tables coming into the statement. You define the from clause as being a collection of labels that get bound to those parameters. You give a name to that select statement by calling it my function. And then the result set, of course, the table is a function of the input tables that are provided. And this function, of course, is the business logic captured in the select statement. The invocation for this kind of a function, of course, is something very simple, just like you would do with scalar functions. It's just calling the function with parameters as you see below. You can just say select star from my function T1 through Tn. And the from part really is the one that supplies the table as a function of table inputs. So maybe let's take a look at an example of what that looks like.
Yep. Thanks, Karun. So let's quickly recap what we did in last demo. So we created a simple currency conversion function in Python. And then we augmented our original SQL to convert our total sales using that function. So table functions are essentially, instead of writing functions in Python, now you're going to create a function to be used in SQL. So let's take the SQL that we've written here and create a table function out of it. So let me highlight this SQL. Under this ... I'm going to say convert to table function. So the SQL that we've written essentially does product aggregation. So why don't I call it product ag? And Scalar has detected that we're using two input tables. So essentially the table functions is going to allow us to create a reusable function where we can pass different input tables, or the input tables have now become parameters. So originally, where Python functions take columns as parameters, table functions take tables as parameters. So here's a table function we just created under table functions, and the graph for it has just popped up. So essentially, we're taking two tables as input, just as we did up here. We apply the same business logic, which was our SQL that we wrote, and we have an output table. Let's see how we can use this in SQL. So I'm going to click on the Use in SQL button. And now Scalar has pasted an example invocation of this table function into my SQL window. Let me make this a bit bigger. So now these 6 lines of SQL have now been condensed into 1 line of SQL. So for me to invoke the same logic on these tables, I can just call them on the same table. So now I'm going to copy paste the same tables here. And now I'll just hit the execute SQL button on this line. And now Scalar has created the same graph for these 6 lines of SQL. So you can see how Scalar provides tremendous flexibility and programmability for developers. So now imagine in a business scenario where you want to apply the same product aggregation for, let's say, a different line of business. Well, all you need to do is just pass in, let's say you have, instead of orders dataset, you have New York City orders dataset. So now you can leverage the business logic you've just built and reapply it on different tables. So another thing we can do here is that we don't just have to do a select star. In our original query, we did a product aggregation, but I know there's a relationship between orders and products in a sense that in the products data set, we have a product category name. So why don't we take our product aggregation and aggregate it to another level, which is a product category level. So I'll select from our table function, which did the product aggregation. Then I'll join it to the products data set. I pop this out. Now I know that the product ID is a common column. And let's group by the product category name. So now similar to this function, let's find the number of items and total sales at the category level. So we'll do count of the rows. Instead of count, we'll do the sum of the number of items. So number of items are coming from our product aggregation. And we'll call this total items. And we'll do the sum of total sales as a total category sales. So we've taken the output of our table function and aggregated it or used it in another SQL. Typo. Let's also add an order by the total items. And we'll run this. So now what we've done is we've used our table function in another SQL function. We've created a brand new graph here, and we've done the aggregation at the category level. So you can see that we've used a scalar function in a table function and also used that table function to do a secondary level of aggregation. So this shows us how Scalar can be used to refactor our code, and it's very flexible for developers. So let's recap. So in this demo, we started with our product aggregation SQL. We then created a table function out of it. We then showed how easy it is to input tables and reapply our aggregation logic to another source, let's say New York City orders. We then use our table function to further aggregate our orders at the category level. So this really shows how Scalar can be very flexible for developers. All right, back to you, Karun.
Thanks, Josh. Next slide, please. So before we move on from this topic of scalar functions and table functions and the select statement in general, I think it's worthwhile to point out how you can use Scalar in production. A lot of organizations and customers that we speak to are building AI ML models, and one of the challenges that they run into is how do we deploy this in production at scale? How do I run this across millions and billions of rows of data and do it quickly and do it without building sophisticated data pipelines myself? And Scale provides a very easy way to do that. What you're seeing here is a normal scalar function, the one that we talked about a few slides ago, but in this case, we're using it to basically be mapped across all the rows in the data set, but to apply an ML model. So all it takes is essentially at the very top, importing the right library. So in this case, we're importing NumPy or Keras, and of course you can import any of the open source machine learning libraries or any of your code, then reading in the model, and then applying the model, as you see in the third line that's highlighted. And that's essentially it. So this function then gets mapped across all the rows that you have and gets the input from the columns that you're passing in as part of the scalar function arguments. And that's how you can deploy ML into production. And this, of course, performs at different levels of cluster sizes. Whether you have a small cluster or large cluster, you can obviously resize it to get the kind of performance that you're looking for. Next slide, please. Before we wrap up the concepts and demo section, I wanted to maybe spend a little bit of time talking about modules, because modules in Scalar, as you would imagine in any sort of technology where you're building things through code, the need to refactor and to modularize your code is really important, and it's no different in Scalar. As you can tell from what's the kinds of graphs that Josh has been working with, they can get quite complex. And how do you refactor it? How do you break it down to logical components that you can easily test, easily reuse, and use in other flows? That's where modules come in. You can break down a very complex graph, test it separately, debug it separately, troubleshoot it separately, and then make it ready for availability as a library of components that other developers in your organization can use to build their data flows. So let's take a look at what that example looks like.
Great, thanks, Karun. So in this demo, we're going to be taking a look at modules. So let's recap what we've done so far. So first, we created a simple select statement with SQL. Then we created a scalar function in Python and used it in that select statement. And then finally, we created a table function out of it And then we created a secondary level of aggregation at the category level. So as we've been developing this data application, at the bottom, we can see that our graph has been growing more complex. So here we see a bunch of nodes, and you can see that it's probably at the level or point in time where we can probably refactor this because we want to go back, we want to read it, we want to maintain it. So this is where modules come in. So let's take this graph and create modules out of it. So on the left-hand side under modules, I'll create a brand new module. I'll click on this plus icon, and really what the graph was doing is it was computing category stats. So I'll call this category stats. Now the SQL that powered that graph was this one, and I know that we have 3 input tables: orders dataset, order items dataset, and then the products dataset. When we're building modules, we have a number of nodes that we can drag in and build our app. So one of those is a source table node. But there's a shortcut for us to add these tables as source table nodes. Under my tables menu, I'm going to go to the orders dataset, click on the ellipse, and click on add to module. Now Scalar has added a source table node for that table. And let me do the same for my order items and products. I added order items, and let me also add products. Let me rearrange these nodes. And now that I have 3 input source table nodes, I'm going to create one SQL node that's going to run the SQL that we had before. I'll click and drag on the triangle and connect these nodes as inputs to the SQL node. First, I'm going to copy this SQL, and then I'm going to configure our SQL node. For the SQL statement name, I'll create a new statement representing the SQL that's going to be run in this node. Since I know it's doing category stats, I'll call it category stats SQL. Then I'll paste our SQL. So you might have seen that the table mapping was updated. So what Scalar did was it went in, it parsed our SQL, and it detected that we're reading 3 different tables. So the table aliases that we've used here, orders, order items, dataset, and products, are being mapped to nodes in the graph. So essentially we're telling Scalar, run this SQL on these 3 input nodes. And the SQL that I'm running here, this is the mapping for that. So I just need to quickly verify that the tables are mapping to the correct labels. So this source table node was called orders dataset, and that is indeed label 1. The order items dataset is indeed label 2, and the products dataset is indeed label 3. So when I hit save, I'll close the warning. Now what Scalar has done, it has taken 3 input source tables and run our SQL on it. So before, you could see our SQL graph was this one. It had many nodes in it, and it can grow to be quite complex. But now we've taken that graph and we converted it into 4 nodes. So this is very clean and very easy to understand. So this is a good example of a module. Now this SQL node had both table functions, it had Scalar functions. So we can write very complex SQLs in the SQL nodes. Now that's not the end of modules. Modules can be hooked in a pipeline to other modules. So let's say we had some SQL like this. We wanted to take the output of this statement, and let's say we wanted to filter it. So typically in SQL, we'd write select star from the output of that, where, okay, let's say we apply a filter to total category sales, greater than, let's say, 50,000. And let's also apply an order by total items. Now let's see how we can convert this to another module and apply it to, and then read in this module. So under out, I can drag in a function output. So a function output enables us to use the output of this module in other modules. So the reference name here, we'll call it category stats _ output. And now I'll create a second module to represent our filter. I'll click on the plus next to new module, and then I'll call this, let's say, filter. Under input, I'm not reading a source table, but I'm actually reading the input of another module. So I'll drag the function input, and I'll configure this function input to point to our category stats module and pick up the category stats output. So you can see Scalar has detected the schema of that output. Now once I hit save, what Scalar has done is pulled in the output of that module. Now I can drag in another SQL node and then configure this to be our filter. So let's create a new statement. We'll call this filter SQL. And we'll paste that statement that we just written earlier. So output is just an alias for the previous node. So Scalar has mapped our output to our label 1, which is our previous node. Now that when I hit save, close the warning, and now Scalar has applied the filter to that output. So now you can see how we've gone from a complex SQL graph and we built 2 modules out of it. Essentially, we created one module out of that graph, which was just 4 nodes plus a function output, and then we attached it to a filter module. So these are the building blocks of building applications. So let's recap what we just did. So in our final demo, we introduced modules. We observed that our SQL graph had many nodes and could grow very large. We then took our SQL code, created a single module out of it, and we showed how this module consisted of just 4 to 5 nodes. And because of that, it was very easy to understand and maintain. We then created a second module, which was just a filter, and saw how easy it was to hook modules together. Now that we have multiple modules, this becomes building blocks of applications that can be deployed into production. All right, back to you, Karun.
Great, thank you, Josh. Next slide, please. So far we've been talking about a lot of the functional capabilities of Scalar, how to build with it and how do you play with the different concepts and artifacts in the feature set in the IDE. I think what's important to point out and highlight, of course, is that Scalar is an enterprise-grade product. You can essentially deploy Scalar at as small or as large a scale as makes sense for your organization. It's a cloud-scale product. You can run between from a single node to up to hundreds of nodes and get linear performance on the data and the data workflows that you're running on it. You can run from gigabytes of data to petabytes of data if need be. On the transactional support side, Scalar supports transactional integrity and asset compliance. So you can imagine if you're working with complex data flows where tables are getting updated over time and your business logic needs to make sure it has a consistent view of the tables even though they're distributed across the cluster, well, Scalar ensures that for you behind the scenes, and you can just simply focus on writing your business logic, and the transactional support is provided by the platform. Scalar also provides backup and recovery in the event of failure, whether it's code failure based on the code that you write or some sort of cluster failure because of power outages. Either way, we do backups, we keep the redo logs, we're able to replay them, and we checkpoint them so you can recreate the previous state where you were and pick up where you left off before the failure. So there's recovery is quite quick, and you don't lose a lot of the work if that does indeed happen. And finally, Scalar has built-in enterprise integrations. We have role-based access to the cluster, and we can work with your enterprise authorization solutions, typical of enterprises, things like Kerberos and LDAP, etc. Next slide, please. So to conclude on the Scalar product discussion and the platform discussion and sort of the demos, one thing to keep in mind, so far we've been talking about the development experience with Scalar. How do you build data marts and how do you build data warehouses and how do you use the different constructs in the IDE to build these applications? One thing we have not covered, which is a completely different universe of capabilities that Scalar provides, is the production experience, the operational experience with Scalar. The good news is with Scalar, when you write the code, you can move it and deploy it on production with with zero changes. Essentially, all your data flows and Scala functions and table functions and parameterization that you've built in, the code ports over with absolutely no changes. You can deploy it onto a cluster that's running either on demand or running always on. You can trigger those data flows based on a schedule. Let's say you're running reports on a daily or hourly basis, or you can trigger it based on a Lambda function, or you can have it always on and just be ingesting the data that's coming in and processing it and producing the output. Either way, you get high performance in the production deployment. In addition to the production execution of the data flows, there's a collection of tools that are available to manage the deployment in production. So things for troubleshooting, we've got various tools built in, like various data marts built in to do log processing to help you figure out what the current state of the cluster is. There's information on the metrics and the performance metrics of the platform that you can tune and play with. There's built-in scheduler that you can use to schedule the execution of the data flows. There's system management that you can do, for example, to configure the cluster to have particular Python libraries available for accessing your Scalar functions. And of course, there's system monitoring to look at CPU utilization, memory utilization, paging, and so on. So there's a whole universe of technologies and tools available to help you deploy and manage Scalar in production, but that's probably a topic for another conversation. So with that, I will hand it off to Nikita to talk through a customer case study. Nikita, all yours.
Thank you, Karun. Hi, folks. My name is Nikita Ogievetsky. I'm running the Scalar Solution Engineering team, and as part of this role, I develop solutions and applications using Scalar. Today, I want to talk about my engineering experience developing a Scalar data mart. To set the context, our Scalar team just finished productionization of a near real-time streaming system at one of the top financial institutions. The wealth management division of the bank provides its customers with consolidated financial information, portfolio analysis, and mark-to-market valuations across all the investments. This data includes balances, historical account statements, client holdings, tax loads, gains and losses, and other details. This information changes frequently due to the trading transactions, obviously, and corporate actions, and it may as well go several years back in history when delayed legal case resolutions take place. So you can imagine the complexity. So with previous Spark implementation, the bank was limited to just daily batches due to a very slow performance, over 4.5 hours for a single batch. Scalar helped boost performance 10x and reduce batch durations from several hours to several minutes over similar infrastructure, thus enabling switching to near real-time updates and reducing costs. Additionally, I must mention, banks, engineers, and managers fall in love with Scalar IDE. With Scalar, they replaced 25,000 lines of obtuse, speaking of job security, Java Spark code with a dozen visually transparent Scalar modules, like the one that Josh showed in the previous demo. And to add to that, also, all these data flows and applications that you develop in Scalar could be checked in and checked out into any code repository. Specifically here, this bank is leveraging GitLab. So while this is the core use case, and I would love to present it one day, but it would require more time. Today, we have just 10 minutes left, and I want to focus on one of the side applications that we had developed while working with a customer to implement the strategic streaming platform powered by Scalar. So let's now move to the actual requirement for this data mart that I will be describing. As mentioned earlier, the bank's streaming platform integrates dozen regional compute-heavy Scalar data applications that continuously process over 2 terabytes of data loaded from HDFS with several gigabytes daily volume of live updates via Kafka streams. Each of these data applications performs complex computes over more than 30 data tables in near real time and outputs compute results back to Kafka. A complex system like this requires a high level of transparency to analyze its internals and identify volume and performance trends and correlations, discover opportunities to improve and catch any bottlenecks before they become problems. So why not do this with Scalar? Let's try it. The data mart we developed to aid this goal empowers BI developers to analyze complex streaming applications and complex event management. So as you see in this slide, the main input into the data mart is the streaming platform application log, the log written by the multiple applications, which includes state changes across all applications, their components, and microbatch stages. As well, serialized objects, for example, applications log sizes and row counts of different base tables and Kafka streams throughout their lifetimes. And of course, errors and warnings, if any. So in this case study, I would like to highlight a few awesome capabilities of Scalar that made my data engineering user experience pleasant and efficient. The first awesome capability that I want to highlight is that I did not have to create and deploy a predefined log parser. Rather than parsing log files on ingest and then kind of figure out the errors and then do it again and again, which would be quite convoluted, I loaded files first into Scalar a single row and as a single column CSV. Then I developed a simple scalar function in Python that applies a basic regex, regular expression, to one row at a time. With Scalar, I could develop it interactively and test it iteratively. As Josh and Karun shared in the earlier session, Scalar map operators run across all CPUs in the cluster and apply Scalar function to all rows in parallel, boosting performance proportionally to the number of CPUs your cluster has. For example, if your cluster has 32 CPUs across all nodes, performance is boosted 32 times. If you have 144 CPUs, it is boosted 144 times. 1,000 CPUs, 1,000 times. A similar performance boost would apply if I run a scalar function that applies machine learning or NLP algorithm, as was described in the earlier session. So the second awesomeness of Scalar that I wanted to bring up is the power it gave me to combine declarative and imperative programming paradigms. The thing is, when you start developing a data mart, you may not yet know what the final data model will look like until you have loaded and profiled the source data and analyzed its patterns. This is kind of catch-22. Scalar allows you to break this evil circle. It empowers the result-driven data engineers who understand the business goal of what they're doing. Scalar programming paradigm allows them, and me specifically, to work iteratively, fine-tuning the solution and data model, developing and testing continuously, one bit at a time. As you see in this diagram, this analyzed block in the middle, the blue block in the middle, once I've finished parsing the data, I am able to start analyzing the data attributes using table profiling and SQL, the two blocks on the top. Then I build the first set of business logic and interpolations using SQL, extending it with Python scalar functions and table functions that you see kind of on the bottom. And then once I got the first level of business logic and the derived tables built, then I do more analysis and more testing, and then next level of development and so forth until I arrived with the final data mart ready to share with the BI developers. Next slide, please. So this slide illustrates how I eventually organized my Scalar data application and refactored it into 3 application modules. Module 1 is the log parsing. As discussed in the previous slide, here we'll outsource files, parse syntax, collate stack traces. Remember that stack traces actually span over multiple lines which need to be associated with the first complete log entry, and mainly extract workflow semantics related to streaming applications and their component state changes, microbatch identifiers and their stages. Once that's done, we move to module 2, data preparation. Here we extrapolate application state changes and microbatch identifiers and enrich the corresponding data records that were produced by the same Scalar application. Thankfully, SQL gives us very easy ways to do that. The awesomeness of Scalar that allowed me to combine the declarative power of SQL with the imperative programming in Python made this task very easy. So now we move to the final module, module 3. Here we compute and build normalized tables. With the main measures and dimensions computed, I now focused on the final computation steps. I exploited objects serialized in log files as JSON blobs into their own data structures to enable tracking size, row counts, and other properties of the live tables of each data application over their lifetime. Look at the bottom left. The reusable table function that I implemented as a set of native scalar operators achieves that. This table function is then used from within SQL statements, similar to the one illustrated by Josh in the earlier demo. Lastly, I prepared the final tables of my data mart and finalized their data models. Next slide, please. Yes, thank you. So here you can see my operationalized data application with dozens SQL operators that I developed interactively and we just reviewed in the previous slide. Now they compile down to hundreds of execution primitives. The callouts show zoomed in sets of operators. Using this view of the execution plan, you can track how data was transformed alongside the execution plan, how the row counts as they traveled from one operator to another, the skew and time taken by each of the execution primitives. This lets you troubleshoot your application and identify opportunities for improvement. This gives you a huge power. This operationalized application can now be either scheduled or invoked as a microservice via Scalar shell distributed along with Scalar. On the bottom here, you can see kind of the snippet of the Scalar shell. Next slide, please. So finally, the data model is exposed to BI developers. While in the previous demo, data analysts used Tableau for visualization, here they decided to use Jupyter Notebook to execute SQL queries against Scalar Data Mart and build visualizations with Matplotlib and Seaborn. So as a conclusion, this quite complex project was accomplished in a very short time in an agile manner, delivering data mart tables in iterative fashion. It was easy to do and it was very efficient. The real value for me as a data engineer was that I was able to build this data mart, designing its data model iteratively while I was analyzing data and developing business logic. No advanced DDL was required. I did not need to pre-create indexes, aggregates, or metadata. Scalar implicitly creates this on the fly based on the data. I was empowered to work on this in a highly parallel fashion without any knowledge of iterators. No niche expertise such as Java, Scala, Python, multi-threading was required. Just SQL and basic Python. Scalar engine took care of the rest. It made me the expert. Scalar, and lastly, the Scalar functions, which really the modernized store procedures, work on rows, columns, matrices, and objects, enabling superior performance on full data sets rather than sample data. So this concludes this use case story. By the way, thank you for showing this screen, Josh. By the way, we just have launched a free Scalar developer offering in AWS. Karun, do you want to say something about it?
Yeah, absolutely. Thank you. Thank you, Nikita. So as Nikita mentioned, we have a Scale Cloud developer offering available on AWS. It's a SaaS offering, so you don't have to deploy it and into your own VPC. You can play with it, and it basically is available to you for free for forever. We don't have a end time for it. It is a small taste of Scalar, so you cannot necessarily run production workloads on it, but there is an attached S3 bucket that you can use to play with sample data. You can attach your own S3 bucket to it. And when you're ready to build more complex data flows, we do invite you to come to the Scalar Marketplace offering. That's a commercial offering. And we'll talk a little bit about the pricing on it in the Q&A session. I know there was a question around that. But to answer the question at a high level, there's a free offering available for Scalar Cloud Developer, and then there's a paid offering in the enterprise side, and we can talk a little bit about how the pricing works there as well. Next slide, please. So we also have a Scalar Cloud Developer promotion going on with Twitter. Kevin, if you would like to speak to that, I'd like to introduce my colleague Kevin, who can tell you more about that.
Yeah, thanks, Karun. Yeah, I mean, you just saw the great demo from Karun and Josh. And so now, we want to encourage you to try out Scalar Cloud in the developer edition, which is free, that you just saw. And so we're going to give you a small incentive to create an account and put your data in and explore and do some of the things that you saw Josh do on Scalar Cloud. So all you have to do is to earn a $25 Amazon gift card. I know it's a small incentive, but is to create an account, log in, import your data, do some exploring, do some coding if you'd like, and follow Scalar Inc. on Twitter and tweet what you see there or something similar, and with a screenshot of you inside the Scalar Cloud app, and we'll DM you an Amazon gift card for $25. So I think it's something simple. It helps both of us, and you get to try out a really cool product, and and hope you like it and play with it. And it'll last until about a week, until September 3rd. So go to it and earn a free $25 gift card from Amazon. Thanks, Karun. Back to you.
Karun, you're on mute.
Oh, sorry about that. Sorry, next slide, please. Thank you, Kevin. So I think this is the link for the gift cards that Eric was mentioning earlier. Maybe we'll take a minute to let people go and sign up. And while we're doing that, we can start to answer some of the questions that were showing up in chat.
That link actually on the screenshot isn't the same as the one you guys gave me, although it might go to the same place. The .html, I don't have it in the version you guys sent me. One of those two will work. I know that the one I pasted into the chat will work. And just for context, for those who got the right trivia questions, and for everybody else who wants their $10 gift card to Grubhub, the link was just stuck into the chat. So please click on that and register. We will be raffling off the Beats headphones at the end of tonight's session after the Q&A that's coming up. So we are going to raffle it off amongst the names who go to that link and actually put your name in and register. So if you don't do that, you won't win the headphones. So it's important to do that. Karun?
Great, thank you. I will just start to go through some of the questions. I know there was a whole bunch of questions that we answered on chat. There was a couple that I didn't answer, so let me address those first. And if there's more, we can certainly start to answer them now interactively, or we can go back and repeat some of the questions that were asked in case people didn't hear them. But I think there was one question around pricing. As I mentioned earlier, we have a free developer offering that you can go and play with today. Is when you're ready to deploy more production-oriented, more complex workflows. There's a commercial offering from Scalar. The way the pricing works is that it depends on the size of the cluster that you deploy, and the way we size the cluster is by the size of the memory footprint that's used in the VMs that you deploy. So imagine if you have a 10 gig memory in the instance, and that will be half the price of a 20 gig instance. At this point, we have something called the Scalar unit. That it's a measure of computational load on the platform that corresponds to about 16 gigs of memory. And as you deploy clusters, depending on the total amount of memory deployed in the cluster, so let's say you have 2 nodes, each with 32 gigs of memory, that's 64 total. That's using 4 XSUs. The cost of a single XSU is about $1 per hour. So that would be about $4 an hour. And so that's how the pricing works. And I think there was another question around, let me just see if I can find that question. How much data can we put into the development account? Actually, before I move on to that question, I just wanted to make sure people had any questions around the pricing, if that made sense. And then we can move on to the other question. Hopefully it made sense. So let me address the question around the amount of data in the development account. So the development account currently will offer you a small instance that you can run in. The amount of data that you can manage with it really depends. It's a kind of a complex function of not just the amount of data, but also the amount of computations you do in it, because the more computations you do, the more state that's created in the cluster. So you can think of it as a cross product of the simplicity of the data or the complexity of the data, along with the complexity of the data flow that you build. So feel free to play with it. at this point, and you'll pretty quickly find out what works and what doesn't, and you'll hit the limit soon on that. But I think easily a few gigs, or maybe up to 5 to 10 gigs should be easily accommodated.
I forgot to mention to everybody, if you guys want to ask a question, stick it in the chat right now, and we'll get to your questions.
And yeah, and of course, if I haven't answered your question so far, please feel free to bring it up again. But at this point, I'm scrolling back to see if there were any questions, and then we can go through some of those questions again that were not addressed. Let me just scroll all the way up. I think there was a question around version controlling with Scalar, as I mentioned, and I think somebody added on to that, is you can version control all the code artifacts using Git. And so that's not just the code artifacts that you build, but also the actual application. You can download it and serialize it as a JSON document, and that itself can be version controlled and used for sort of CI/CD purposes to control what deployment of the data flow that you have in production. Oh, looks like there's a new question. And Nikita, Josh, please feel free to jump in and add your comments as well.
I'll read the questions out if that makes it easier. How does Redshift and such AWS toolkits fit into Scalar? That's asked by I think that's a Sid Street.
Yeah, so Redshift, is you could imagine, as we mentioned earlier, is sort of the modern version of the traditional notion of data warehouses. So you can certainly use Scalar to do a lot of the querying and the computations that you would use as a prelude to loading up Redshift. One of the things one point of differentiation, of course, is that you will keep your data in Redshift for a long period of time and continue to pay for it, whereas with Scalar, you can just load it, do the computations, do the querying, and then blow it away and be done with it and not really have to keep that state around. It really depends the kind of data that you're managing and what you're trying to do with it.
And Michael? That's Mikhail Drachuk, excuse me, asked if you can use arbitrary Python libraries in Scalar functions such as loops.
Yes, you can do that. So basically, you can pip install. There's a special Xcalar pip that comes with a Scalar shell that I kind of spoke about, and you can basically add your kind of pip install your modules in your own environment, and then use them from your Scalar functions. And then the next question. Is it possible to define a table?
Oh, from Mikhail also.
I run through some. Yeah. All right. Can you load incremental data into data mart using Scalar? Yeah. So actually, Scalar comes with the integration with Kafka, for example, and as well as other CDCs that coming later. So yes, the answer is yes.
And the question from Mikhail Drew again.
This is actually. So sorry, and this is actually the main use case that I started with. This is exactly their multi-partition Kafka streams that floating over a few dozens of Kafka topics. That was a deployment that we just kind of helped one of our key customers to complete.
Okay. Mikhail asks, is it possible to define a table that takes Scalar inputs and produces a table?
Good.
This is.
Yeah, go ahead. Thank you.
There is a ways to do that through basically by converting it first into a single row and then turning it into a table.
Michael asks a good question. I like this one. Do you have connectors to data stores like MySQL, or do you need to first dump all the data into S3 to get it?
We actually do have connectors to. And I'm not sure what the free developer offer comes with as we are releasing, but we do have connectors to MySQL, Postgres, and a few other databases.
Okay, and Sankalpa asks, well, I guess I'll reword his question. Can it be deployed on Kubernetes?
It can be deployed to pretty much anything, but this free developer account that we are offer is actually in AWS, but it can run on-prem and it is fully containerized.
Okay, Nag asks, what is the underlying engine to persist the data? Is it S3 or some other database engine?
Yes, that database engine is called Scalar.
But if you want to export the data out, you can export to S3 or use a different connector to export to a different source.
Yeah, you can import from anywhere and you can export to anywhere.
Have we missed someone's question? Because this, I think we caught up in the chat there, but there was a bunch before that were answered before within the chat. Well, one person asked, they have their initials only, RE, is Dremio a competitor? Or do you offer something different?
I believe Karun answered that.
In the chat though, no?
Sorry, what was the...
Is Dremio a competitor? Did you answer that already?
I did.
Oh, sorry.
You know, there's a set of use cases you can use for Dremio. Dremio tends to be, works with Apache Arrow and tends to be oriented for use cases that are very aggregate oriented. That's why it works with the Parquet files, and if you're trying to do things like aggregates very quickly, it certainly makes sense. Scalar is more general purpose. You can do any sort of relational computation with Scalar, not just the aggregates. Of course, we can do that really fast, but you can do any sort of complex relational compute workflow that you want to build and transform your data and build complex data marts. It's not just for a very narrow use case. I would imagine that Dremio is really good at what it does, but it's a limited use case.
If anyone's got questions, please stick them in the chat right
Actually, I want you to, hey, Nag, by the way, how are you? And hi, Sankalpa. Hey, guys. So, Nag, to your question about what's the underlying engine. So the engine itself is Scalar. It's a proprietary engine that is kind of the secret source of the performance and other cool things. But, for example, for the checkpoint recovery and things like that, we do, there's a serialization on the local SSDs or S3, or as well you can export and load it into any other media.
Okay, does anyone have more questions? I'm going to remind everybody to go to the Scalar Grubhub link, which I'll stick right back into the chat. Someone will win a pair of headphones tonight, but you got to register. If you don't put your name in there, we won't be able to pick you. Tony asks, can we use it in Azure? I'm assuming he means, can we use Scalar in Azure?
It's something that we make available currently on AWS, but there are plans to make it available in other clouds. Just stay tuned, and hopefully that's coming soon. I think I also wanted to just answer one of the questions from Nag. He said, what's the underlying engine to persist that data? As I mentioned earlier, you can certainly serialize your final data to S3 if you want. So Scalar can do that for you. Hopefully that answers the question.
So Nag asks, he created an account. Now, how does he access his files in S3 using Zone VPC?
That was fast. We'll be happy to help you if you send me an email. In fact, if there's any follow-up questions, please feel free to send us emails. Let me put my email here in chat. And Nikita, if you could do the same, and Josh.
Yeah, we can chat with Nag.
There should be a quick start guide with the Scalar Cloud.
Michael, I don't follow your question. Can you please put that in a full sentence in there? Unless someone else can make out what he said. He wrote, or spacing out production queries.
No,
I'm sorry, he wrote it in two halves. I missed the first half. Okay. How does it handle concurrent queries? Would you recommend having multiple instances for multiple developers or spacing out production queries?
I I think, yeah, go ahead, Nikita.
Yeah, so as a matter of fact, so one of the deployments that we've done just now, there are 50 parallel monstrous applications running completely in parallel, and they have multiple queries, just not a single query. So it's basically, they compile down, the execution plan compiles to 1,000 operators, basically.
So you can imagine.
It's like it's more parallel than anything you can imagine.
Kevin, how are we doing in terms of count? Do we want to give it a little longer before we raffle off the headphones? You're on mute. Kevin, you're on mute. I could see your mouth moving, Kevin, but you are still on mute.
Sorry. Yeah, I'm almost ready. Give me a few minutes, and then we can do the raffle.
Can we take another question? Anybody else have something? I could ask more trivia questions, but the cat's out of the bag. You're all going to win.
Okay.
For it. Thank you.
Okay, Eric. So,
yes.
So I have everyone that has registered for the raffle and the gift card. So there's a total of 48 people that have done it. And so Eric has not seen my spreadsheet. So we want to try to make this as random as possible since we're new in this virtual world. So Eric, why don't you name a row number? And then I'll share my screen with the spreadsheet and I'll show everyone the row that you picked and that person wins.
So I'm going to nominate Peggy and Nika, who just both said 42.
Okay. Okay, hold on. Let me share my screen and we'll see who 42 is. 42 is Nag Chadella.
Hey.
Nag, we're on mute. Here we go. Wait, hold on. Nag, I'm unmuting you. Ask to unmute. Hold on.
So
I hope you. There you go. Nag, are you there?
Yes, I'm here.
Congratulations! You just won a pair of really expensive Beats headphones.
Thank you very much.
yeah. So Nag, if you can email me, I'll put my email in chat. If you can email me your address where we can ship that Beats headset to, then we will have it sent out to you as soon as we can.
Yeah, thank you very much.
Hold on just a sec. Let me get back on and unshare my screen and put my email.
Hi Nikita, how are you doing? It's been a long time.
Sorry, sent that to just one person. Oh, why is it? Hey, for some reason I can't chat to everyone. Can someone on my team? Yeah, there. Chat to everyone.
Sure, go ahead.
Chat my email to everyone. Kevin Lee at Scalar.com, or chat to Nag, at least me.
Kevin, you have co-host access. You should be able to. That box above the chat that says 2, you may be having an individual.
I email to Nag who won. So
okay,
just send me an email with directly with your shipping information, and we'll get that Beats headset out to you.
Congratulations. Okay.
Sorry, Eric, just one thing to point out is that the preferred browser to access your free developer Scalar account is Chrome. It works best in Chrome.
I think in this day and age, it's the preferred browser for just about everything. Okay. So if we have another few question that comes in the next minute or two, we'll take it. Otherwise, our speakers will be here for one-on-one questions. They're going to hang out in the chat a little bit afterwards, and I will selectively unmute people if that works. If not, then we will just continue back to the text chat if it gets too background noisy. Other than that, though, I do want to give a great big thank you to our speakers, Nikita, Karun, and Josh. And of course, as well as a thank you to Kevin for raffling off those headphones. If you could all stick in the chat your appreciation or clap. I think there's a way to virtual clap on this on Zoom. You're under reaction. So if you kind of do that, since it's the closest thing we got to real human interaction, and then we'll take the next questions, and we'll keep taking the questions for basically as long as they flow. Then Michael asks, what did you build the front end with? That's a good question.
We built it with the secret sauce.
What's that sauce taste like?
Well, it's actually a lot of these JavaScript libraries are custom built, but of course we use some of the basic libraries as well.
Trying to make sift through the chat to see if there's some more questions. Peggy wants Firefox back. Okay, never mind that. We're not doing that. I think that's it for the questions for now. Our speakers are going to hang out in the chat another few minutes. If you think of a question, good. If not, you got their contact information, and we'll go from there. So I want to thank everyone for coming. I hope you all enjoyed. Yay. It's so odd not to have like an audio response. Usually it's, clapping and stuff, but this is what it is, the world we live in now.
That's an addition we need to add to Zoom, a clapping sound.
Well, there's a clap thing under reactions, I believe. I'm working on mine, though. When I click it, nothing happens. Maybe nobody else can either. Oh, wait, no, here it goes.
But it's silent.
It's silent, yeah. It should come with an audio effect.
Eric, we have another question from Michael. Is pricing information available on the website?
By any chance?
Not at this time.
Okay, so Ari says I should take everybody off mute. I guess I could do that as an experiment, and I'll have to mute everybody if it doesn't work. So we'll see, because there's not most of the people dropped off now. Let's see how I can get everybody in one shot unmuted, though.
I think you're muted.
Oh, the folks asking to take them all off mute so that they can clap. Uh-oh.
I think we can unmute ourselves.
I think you're unmuted, but you have to click unmute.
Okay. Now we're clapping. Yay! Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Eric, you're speaking, but you're muted.
My screen.
Oh, now you're muted again.
Still muted.
Was that weird? Okay, I don't know how that happened, but okay. And Nika said to me I'm muted, but the button said, all right, the button's showing the reverse of what it is. Now it says I'm muted. Okay, never mind. Thank you, Nika, for telling me, even though I couldn't turn it off. Anyway, I don't see any more questions, so thank you all for coming. If you have any more interesting questions, send them along to the speakers tonight, and I'll see you all at the next event. Thank you all.
Thank you.
Thank you.
Thank you.